Okay, I'm start the recording now. And for this chapter, I have changed the sequence because I'm a little worried about that you may have some problems setting up your Java environment. So I put the chapter 2 in advance so that we can have more office hours for those who are not familiar with Java. And for this chapter 1, it's quite easy. So don't worry about this thing. And I will go through all the required concepts for the chapter 1 here. Here, we have to know that Java is one of the world's most widely used computer programming languages, and also there are some other things like C++, C, Python. Those are also widely used. And in this course, you'll have to learn to write instructions in the Java programming languages and commanding computers to perform some tasks. And also you will learn some softwares to control the hardware or computers. And here we will only touch a little bit about object-oriented programming. And in the next week, we will dealing with something related to the software objects. And here we still have to know that for many organizations, the preferred language for meeting the enterprise programming needs is Java. And it is also widely used for implementing the internet-based applications and the software for devices that communicate over a network. And there are billions of personal computers in use and even larger number of mobile devices with computers at their core. Then this means that the computers and the mobile devices, that means Java can not only implement the compute-based programs, but also for the mobile phone devices, edge devices, we also can using the Java to implement the software. I'd like to show them. Okay. Okay. And according to Oracle's Java 1 conference keynote, that there are 10 million Java developers in the worldwide, and it runs 15 billion devices, including 2 billion vehicles and medical devices. So as we can see that Java is pretty widely used in all kinds of environments. Okay, instance. Okay. Okay. Yeah. And these are a list of the devices we can use with Java. Just have a look over it, have a concept of it is enough. And for our required textbooks, and it is based on the Java Standard Edition, that is 8. However, when we are doing our demo, we are using 21 or 25. They are almost the same thing, just for the advanced versions, they have some new features there. And usually the standard edition contains the capabilities needed to develop a desktop and server applications. So you'll have to remember desktop, and server. And prior to Java SE8, Java supports 3 programming paradigms. That all the 3 you have to remember, because the first chapter you have to remember a lot of details in case that you will meet some multiple choices in your W3 school exams. And I will highlight all the details we need to remember. And Java SE8 added the beginnings of functional programming with lambdas and the strings. That means after Java JDK 8, we can use the functional programming and with lambdas and the strings. So here it is an introduction for the Java Enterprise Edition. That Java is used in such a broad spectrum of applications that it has 2 other editions. One is the standard edition. The other one is the Java Enterprise Edition, Java EE. It is great, geared towards developing large-scale distributed networking applications and web-based applications. And also there is the micro editions. It is a subset of Java standard editions, and it's geared towards developing applications for resource-constrained embedded devices such smartwatches, MP3, television setup, and smart meters, and more. So you have to remember here, one is for resource constraint. That is for this edition. Here, it is for the large-scale distributed applications. This is the enterprise editions. You have to figure out these 2 different editions towards different devices. And for the hardware and software part, that a computer can perform calculations and make logical decisions phenomenally faster than human being can. Today's personal computers can perform billions of calculations in 1 second, more than human can perform in a lifetime. Supercomputers are already performing thousands of trillions or quadrillions of instructions per second. Okay, we can skip it. These slides seems nothing need to remember. And computers process data under the control of sequences of instructions called computer programs. Here we have to remember this line. A sequences of instructions is called computer programs. And these software programs guide the computer through ordered actions specified by people called computer programmers. This is the human, us. We are programmers. And in this course, we'll learn a key programming methodologies that enhancing programmers' productivity, thereby reducing software development cost, OOP, objective-oriented programming. Once in the future, if somebody mentioned OOP, you have to know that it means objective-oriented programming. And a computer consists of various devices referred to as hardware, such as keyboard, screen, mouse, hard disk, memory, DVD devices, and the processing units. You have to remember all these things. In case they ask you, please select the hardwares listed, and you will have to figure out what kind of things are hardwares, what kind of things are softwares. And computing costs are dropping dramatically owing to a rapid development in hardware and software technologies. Computers that might have filled large rooms and cost billions of dollars decades ago are now inscribed on silicon chips, smaller than a fingernail, costing perhaps a few dollars each. So Here, please remember this thing, silicon chips. It is the keyword for this sentence. And silicon chip technology had made computing so economically and that computers have become a commodity. Here, for the Moore's law, every year or two, the capacity of computers have approximately doubled inexpensively. This remarkable trend often is called Moore's law. Named for the person who identified the trend, Gordon Moore, co-founder of Intel. Moore's law and the related observers apply especially to the amount of memory that computers have for programs, the amount of secondary storage, also such as the solid-state driver storage they have to hold programs and data over longer periods of time, and their processor speed, the speed at which they execute their programs. Let me see. To the amount of memories for the programs. Here, you have to understand what is a secondary memory, that it can refer to the solid-state driver storage. And for the first one, that is RAM. So you have to distinguish them. And similar growth have occurred in the communications field. Costs have plummeted as enormous demand for communications bandwidth, that is the information carrying capacity, has attracted intense competition. Such phenomenon improvement is fostering the information revolution. Okay, here we can skip this slide now. And computers can be envisioned as divided into various logical units or sections. Here you have to remember the logic units. So what are the logical units? There is a list, given a pretty detailed description. However, what you have to understand is, please always remember the name of the logic units, such as the input units, right? It is receiving section of obtained informations from input devices, such as our keyboard. And for the output units here, so this is a shipping section, makes information the computer has processed and placed it on the various output devices, such as the computer screen or touch screen, something. And the third one is the memory units. What is a memory unit? That is something like a warehouse section returns information that has been entered through the input unit, making it immediately available for processing when needed. And here it has a description for the main memory, RAM. And the previous slides, we have mentioned something about the second memory, right? The second one. You should refer to the, okay, does it has the pages? No, 1.21. You should refer to the section 1.21. And the other logic units is the arithmetic and the logic unit that the programs can, like adding or subtractions and doing some multiplications, such a calculations unit. Okay, what you have to know is that For the ALU, they are performing the calculations. And for the central processing unit, this is what we call CPU there. This is the administrative section coordinates and supervise the operations of the other sections. And the CPUs tells the input unit of when the information should be read into the memory units and tells the ALU when the information from the memory unit should be used in calculations, and tells the output unit when to send information from the memory unit to certain output devices. Here it still have some descriptions for the secondary storage unit, so we can update here. I cannot write. Okay, here we are going to introduce some data hierarchies. Data items processed by computers forms a data hierarchy that becomes larger and more complex in structures as we progress from the simplest data items called bits to richer ones such as characters and fields. In our previous demos that we say a data type int is 8 bytes. Right? I think, or something like that, related to that. So this is quite different from bits. They are different. A bits means the smallest calculation units. Like if I write 1 using 4 bits, that is 0, 0, 0, 1. This is the binary representation. And 3, that is 0, 0, 1, 1. Why? Because for 1 is this, right? For 2, if 2, 1 get together, 1. This is 2. So plus this 1, this is supposed to be 2. However, in binary representations, we will only keep 1 here, and there is a carry forward here. So that is the 2. And for 3, sorry, not here. Since 2 is represented like this one, if we plus 1, it's going to be 3, right? So 0, 0, 1, 1, 0, 1. So in this case, 1, 1, 0, 0 get together. And this is the binary representation of 3. And those are bit streams, we say. This is the simplest data items, we said, called bits. Okay, and here it is the data hierarchies. Like everything was saving in a file, right? And we have a record that's Judy, and we'll refer to this line. And this is green, will refer to the second block after Judy. And this is the bits. It means here, oh, sorry. This bits is 1. However, for the whole block of this, it refers to the J here. That is the data representation, and we also call it data hierarchy. And the bits is the smallest data items in a computer. We can assume that's the value 0 or the value 1. Such a data item is called a bit, short for binary digits or binary streams, a digit that can assume either of the two values, 0 or 1. Please always remember, if we are referring something bits, that means that things will be contained values of 0 and 1. No 2, no 3, no others, only 0 and 1. These two kind of values. And remarkably, and the impressive function performed by computers involved only the simplest manipulation of zeros and ones. It examines a bit's value, setting a bit's value and reversing a bit's value from 1 to 0 or from 0 to 1. So for characters, and we prefer to work with decimal digits. What are decimal digits? Decimal digits means that such kind of value includes the digits from 0 to 9. For binary, only binary, only 0 or 1. For the decimal, we can using 0 to 9. That's the difference. And uppercase letters upper A to upper Z, and lowercase letters from A to Z, and special symbols like that. Digits, letters, and special symbols are known as characters, and the computer's character set is the set of all the characters used to write the program and represent data items on that device. And computer process only ones and zeros, so every character is represented as a pattern of ones and zeros. You have to always remember that even a character like A, it will have some patterns like 1, 1, 0, 0 here ahead, some patterns like that. It means A. And for B, it may look like 1, 1, 0, 0, 1, something like that. And it is just a example, not the real representation. So you just need to have a concept of it, that everything in the program, when the computer executed, everything is represented as a patterns of ones and zeros, no exceptions. And Java uses the Unicode characters that are composed of 1, 2, or 4 bytes. As we mentioned earlier, here we use bytes to organize the bits. Like 1 byte is equal to 8 bits. 4 bytes is equal to 32 bits. That means if I declare int I is equal to 1, that means in the basic representations, the variable I is represented as let me move it. Oh, sorry. Or 32 bits, because int is a 4 bytes long data type. So we use 32 bits to represent the integer I variable here. And since it only contains the value 1, so here everything previous 1 is 0. We only keep the last digits. We say the lower bits here to be 1. If it is 2, it will be supposed to be 1, 0. But since we're only representing the 1, this is the 32 bits representation. And the Unicode contains characters from many other words language. Like we say Chinese, we can use Unicode, Arabics, and also some Spanish or Japanese. Both of them can use Unicode to represent. But it is not very important in this slides. Okay, then we will introduce fields. And just as the characters are composed of bits, fields are composed of characters or bytes. A field is a group of characters or bytes that conveys meaning. For example, a field consisting of uppercases and lowercases letters could be used to represent a person's name, and the field consisting of decimal digits could represent a person's age. We can say, like, in the next week, we will get in touch with some object-oriented programming. Here, we may declare an object like people, and we will use some fields like we declare variables type is string. We say it is name, right? And since we declare a variable is name and we assign the value to it, that is Alice. Or we declare a variable that it is age, right? And we assign the value 18 to it. In this case, both of these are fields because they are a group of characters or bytes conveys meanings. They are not class, they are not methods, they are just the fields. And for records, several related fields can be used to compose a record, implemented as a class in Java. So here you have to remember a record is implemented as a class. For example, in the payroll systems, the record for an employee might consist of the following fields. And this is possible types for these fields are shown in the parentheses. Like employee identification, a whole number, we say we can declare it as int ID is something, as long as it is a whole number. So it corresponding to the data type int. A name, a string, we say string name is equal to Alice. And address, a string of characters. So it is still, we declare it as a string type. Like 451272 Street, right? In the Manhattan, NY something. This is the street. An hourly pay rate, a number with a decimal point. Here it says that it is a number with a decimal point, so we should declare it as a float rather than an integer. Pay is like 18.50. Yes.
I have a question. So for
Okay.
the address, it's a string of characters, but since there's digits in it, Why isn't it an integer?
Um, you say here, right?
Yeah, 45-12. Those should be integer values, right?
Yes, they are integer values. However, if you can remember that we always say that we always using double quote to
Yeah.
indicate a sentence. Everything
Oh,
in the double quote are string.
I
Uh,
see, I see.
yeah, for this one, we don't like ID is equal to, we don't include this thing, right? We only include the number here, no double quote. So that is the difference.
Thank you, Professor.
It's okay. That's why this part is a little bit boring and maybe complexing. And for the Java programming, only when you code and you will find the difference. If you code more, you will get more familiar with why we are doing that. Something we are talking about, the things I'm talking, like I using my mouse to teach you how to code. It's nonsense. Only when you use your hand to code, you will have a sense of why it is should be like that. But it's okay. Thank you for asking. And for the year-to-date earnings, since it is a number with a decimal point, so it's the same thing that we should declare it as a float. Like earnings. Maybe 80,000 something. You know how much they pay me for 1 hour to teach you? It's quite a lot.
How much?
The hour rate is 100.
No way.
You can check. That's why a lot of people pursuing the masters and the doctors because for the I can show you.
It's a long journey to your position.
No, it's not long. In CUNY, if you can actually in America, you are not required master's degree to go to your PhD. Even if you are bachelor's, you can go into a PhD and get some teaching jobs. Like and I am the adjunct. For those 4 times, they are even get higher pay.
Maybe I should change my major
And
now.
here, adjunct lecturers, 100. So if you study hard and working hard, you can get a pay like that. But I would say that go to industry, you can make more money. Go to industry. As I know in Amazon, they pay their master's employee around as my classmates in my master's go to Amazon doing the very basic thing. They pay him these dollars. However, for the professors, assistant professors, right? We only have 80,000 a year, 80 or 90. Industries, they give you much higher pay. But this is for masters. So I would recommend that you complete your bachelor's and then working while doing a master's. For a master's, the Georgia Tech, right? GT, you can only need to pay around 7,000 and you get such a master's degree. And then you can apply for jobs in industry and you can also eligible to apply for an adjunct like me. But for an adjunct, I only get this rate, not so much. So good luck to you guys. I will give you good grades, even though you are not doing well in my course, because I know for the first course in programming, it's always difficult to get good GPA. But in case you may apply for a master's or something, they require you to get a higher. Only they may looking. I mean, for those schools, they're always focusing on GPA. No matter how you program well, only GPA makes sense. I know it's not fair because a lot of students, a lot of programs, they are programming pretty well. However, their GPA pretty low, so they have no access to the prestigious schools. But anyway, as long as we are trying, we can make everything fine in the future. But don't worry about this course. I will give you pretty nice grades. Okay, I'm talking too much, not related to our course. Okay, let's continue. And for the amounts of taxes withheld, here we may declare a same float point, like tax. The tax may be 1,000 something, right? So since it is a decimal point, this is supposed to be a float. And one thing still have to remember here, I forgot. If you are declaring a float number, where is my pen? Here. We always need to add F here. Okay, this is a record, and we also say that is a class in Java. And a file is a group of related records that we say java.file, right? Java, we once compiled such a thing that welcome.java. That this is a file. That is a group of related records. More generally, a file contains arbitrary data in arbitrary formats. In some operating systems, a file is viewed simply as a sequence of bytes. Any organizations of the bytes in a file, such as organizing the data into records, is a view created by the application programmers. And then we are going to talking something about the database. Let me see what you should remember here. So a database is a collection of data that organized for easy access and manipulation. The most popular database model is the rational database, in which data is stored in simple tables. Here is pretty important, rational database. That is SQL. Of course, there are some non-rational relational database. We say that is something like MongoDB. But currently, you just need to remember this. SQL, it is a relational database. And they stored informations in simple tables. A table includes records and fields. For example, a table of students might include first name, last name, major, year, student ID number, and GPA. And you can regard it as something like the Excel. And the data for each student is a record, and the individual pieces of information in each record are the fields. And you can search, sort, otherwise manipulate the database on its relationship to multiple tables and databases. Okay, nothing too important. Okay, and the big data here. The amount of data being produced worldwide is enormous and growing explosively. According to IBM, approximately 2.5 quintillion bytes of data are created daily. According to Salesforce, blah, 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 blah. Okay. It doesn't make any sense of these slides. Let's go here. Okay, here, this is pretty important and you have to always remember. For 1 KB, it is equals to 1024 bytes. And for 1 MB, okay, we should say, like, how about we go through here? Like 1 GB is equal to 1024 MB. And it is equals to 1204 KB. And this is the most frequently used when we are talking about the memory. So, and you have to always remember, when escalate the levels of the units, you should always multiply by 1024 here. And for machine languages, assembly languages, and high-level languages here. Let me see. Programmers write instructions in various programming languages, some directly understandable by computers and other requiring intermediate in translation steps. For this, they divided into 3 general types: machine languages, assembly languages, and high-level languages. These 3 types you had always to be remembered. And for machine languages, any computer can directly understand only its own machine languages defined by its hardware design. That means, like, Chinese speak Chinese, Americans speak English. Generally, they consist of strings of numbers and that instruct computers to perform their most elementary operations at one time. And those things are machine dependent. A particular machine language can be used on only one type of computer. Although I don't agree with its saying, but for this required textbook, it's fine. We just need to remember it, okay? A particular machine language can be used on only one type of computer. Okay, this means a type. Although I still don't agree with it, but it's fine. For the assembly language and assemblers, those are English-like abbreviations that represent element operations format of they form the basis of assembly languages. Translator programs called assemblers convert the early assembly language programs to machine languages. So here you all have to understand that the assembly languages formed the basis of the assembly languages. And those translator programs are called the assemblers. For the high-level languages, those are single statements accomplished substantial tasks. And the compilers convert high-level languages to programmers to machine languages. That allows you to write instructions that look almost like everyday English and contain commonly and used mathematical notations. Like a payroll program written in high-level languages might contain a single statement such as gross pay is equal to. These are pretty high-level language that we can read and we can understand, but the machine don't understand. That's why we will have a compiler to convert the high-level language program into machine language. So that is this is an important thing you have to remember. For the interpreters, it compiles a high-level language program into machine language can take considerable computer time. Interpreter programs developers to execute high-level language programs directly, avoid delay or compilation, although they run slower than compiled programs. If you can remember in the second lecture, we are talking something different of the C++, C, and Java here, and that they are quite different from Python. In Python, we have our source code, and then we use an interpreter, and then we can get the output, or we say the result. However, in Java, C, and C++, when we have the source code, we need a compiler to transform it into a machine language. And then we can, only after the compiler conduct the extra steps, we can get the output. That's the difference. So it is a one-step thing. One step. However, it is multiple steps. That's the difference between them. And they will ask you something like, who is running slower? And this time you will have to know that it is the interpreter always runs slower than compiler. Here for the object things, and objects are more precisely the classes objects are coming from the reusable software components. We will talk in it more in the chapter 3. And here we will just go through some notions of it. And there are some data objects, time objects, audio objects, video objects. Everything can be seen as an object in Java programming. And almost any none can be reasonably represented as a software objects in terms of attributes, like the name, color, size. The attributes is used to describe such an object. And the behaviors, like what's the method, what we can do, or what the programs can do with the attributes. Software development groups can be used a modular, object-oriented design and implementation approaches to be much more productive than earlier popular techniques like structured programming, OOP, are often easier to understand, correct, and modify. So here, nothing very important. Here, automobile as an object. Actually, in Java programming, everything can be as an object. But here it gives us an example like automobile. So let's see how it describes. So let's begin with a simple analogy. Suppose you want to drive a car and make it go faster by pressing its accelerator pedal. Before you can drive a car, someone has to design it. A car typically begins as engineering drawings similar to the blueprints and describe the design of a house. Drawing includes the design for and accelerate pedals. Pedal hides from the driver and the complex mechanism that actually makes the car go faster, just as the brake pedal hides the mechanism that slows the car, and the steering wheel hides the mechanisms that turn the car. And it enables people with little or no knowledge of how engines, braking, and steering mechanisms working to drive a car easily. Before you can drive a car, it must be built from the engineering drawing that describes it. So a complete car has an actual accelerator pedal to make it go faster, but even that's not enough. The car won't accelerate on its own. So the driver must press the pedal to accelerate the car. Oh, the language is too much. So what is saying that you can just take a car, okay, 4 wheels, as an object. And it will have some other things like the pedal, right? And the brake pedal, that's same thing. Okay, since its word is too complex, I will conclude these 2 slides. That means we can take the automobile as an object, and then we give it a name, and we give it some other attributes. Those are attributes. Like name, color, speed, something else. Those are attributes. And also we can give it some actions, behaviors. Like speed up, 10 miles, or slow down, 10 miles. This is plus 10, this is minus 10, or stop. Those are behaviors, and those are attributes. That's the difference. And everything of the attributes and behaviors are within an object that is owned by the object. And for the method and classes, performing a task in a program requires a method. The method houses the program statements that actually perform its tasks, hide these statements from its users, just as the accelerator pedal of a car hides from the driver the mechanisms of making the car go fast. In Java, we create a program unit called a class to house the set of methods that perform the class task. That is what we state an object also, to house the set of attributes and the behaviors. And a class is similar in concept to a car's engineering drawings, in which house the design of an accelerator pedal, steering wheel, and so on. For instantiations, well, currently it might be a little bit abstract, but from the chapter 3, we will do instantiations for certain kinds of objects. So here you just have a notion of it is enough. It's kind of a little boring, but we still have to go through it. Just as someone has to build a car from its engineering drawings before you can actually drive a car, you must build an object of a class before a program can perform the task that the class's method define. And an object is then referred to as an instance of its class. For a simple explanation, that means we say like for illustrate the object and an instance. The object is more like a template. We say we have a vehicle, or we say the object is animal, right? An animal has a name. And it has a body, right? And it has we say maybe has hair, or they can eat, right? And they can run. This is behaviors. These are attributes. This is behaviors. When we say instantiation, we say we give it a concrete example. Like here this is a animal class. And we make it concrete, that is a cat. It is a certain kind of class. And for the cat, we have a name. Like Mimi. And it has a body, a long body, and soft. Right? And it has hair. Some has long hair, some has short hair. We don't know, but at least they do have hair. We just give it a pretty concrete description. That means we instantiate it. And for the cat, it eats, right? It has a eat behavior. It eats something like a mouse. And some vegetables. This is a behaviors. And it can run, right? It runs fast. So when we are talking instantiation, that means that we give a certain kind of class, making it more concrete. Concrete to like something can be described in a true way. That means the instantiate. Okay, we will go to the next slides. And reuse. Here he said that as the car's engineering drawings can be reused many times to build many cars, and you can reuse a class many times to build many objects. Reuse of existing classes when building new classes and programs can save time and effort. In these examples, that for reuse, apart from animals, they have such kind of patterns. Maybe there are some micro animals, right? The things that we cannot see. They still have such kind of attributes and behaviors. So in this case, we can still reuse such kind of thing for those classes. That is the reuse. Or we can say there is an alien class. They also have such a kind of thing there. So we can reuse all the attributes and behaviors that animals have. It's just an assumption. Everything is depends on your design. You can define your programs whether or not to reuse something from the other programs or existing programs. And using a building block approach to creating your programs, it will avoid reinventing the wheel, using existing high-quality pieces whenever possible. This software reuse is a key benefit of OOP. And for those such a kind of thing, when you are transferring to a third year or fourth year college, they may provide a course like software engineering or software application. In that course, you will learn and practice a lot of building blocks that you may going to reuse the instructions or statements in your program. But currently, we're just learning such concepts. And for messages and method calls, when you are driving a car, pressing its gas and the pedals send a message to the car to perform a task, that is, go faster. Similarly, you send messages to an object. Each message is implemented as a method call that tells a method of the object to perform its task. We're still using this example. For those behaviors, we say that it is a method. because it is something the program or this class can do, like eat or run behavior. The messages is like it eat mouse and it runs fast. Those are messages that transmitting between the classes and the timing. Like currently here, for the cat, it may eating mouse, but in the after 10 minutes, it may eat vegetables. We can use such a method to transmit the messages between different timing. And for the attributes and the instance variables, we have described it as in the previous slide. Attributes, just something like the fields. I give it a name. I give it a variable color to indicate whether it is a white cat or a blue cat. And you can give some other attributes to your object. And there are something encapsulation and information hiding. In OOP programming, we will get involved a lot using the encapsulation and information hiding. But in our course, since we are only Java, not advanced Java course, we will, in the chapter 8, I think, we will only get a little bit, touch a little bit with it, not too much. But in the industrial practicing, you will, if you are going to an intern or you are doing your own project, you will get involved a lot with the classes and encapsulation. Because only when you are doing such, when you are programming in such a way, you can organize your code in a very clean and logic way. And the objects may communicate with one another, but they are normally not allowed to know how other objects are implemented. Implementations details can be hidden within the objects themselves. Information hiding, as we'll see, is crucial to good software engineering. And one thing I can share in advance is that in some of our objects, we use the keywords like public something, right? PSVM. This P means the public. However, we can still using private. If we are using the private, that means other objects, they may communicate here, but they may not if we are using the private. So we will have some demos in the chapter 8. Just have a notion of it is enough. So inheritance, a new class of objects can be created convincingly by inheritance. The new class, called the subclass, starts with the characteristic of an existing class. Like we have a existing class that is the father. And we can inherit it. And making another class is son. And of course, we can have the grandpa. That is the superclass we use. That is certain kinds of inheritance. And interfaces. Those are collections of related methods that typically enables you to tell objects what to do, but not how to do it. In Java, we say it's supposed to be a kind of abstract class, and we will see it in chapter 10. And hopefully, maybe in your advanced Java programming, you will get involved with the interfaces, but not in our class. So we will skip it. And here is for the object-oriented analysis and design. That means how will you create the code for your programs, like program instructions? For example, for the cat example, will you give it attributes of name, color, for distinguish it from the other classes or not? And you should follow a detailed analysis process for determining your project's requirements. And you still have to develop a design that satisfies your analysis. Specify how the systems should do it. And you should also carefully review the designs there. Analyzing and design your system from an object-oriented point of view is called an object-oriented analysis and design process. Languages like Java are OOP, allows you to implement the object-oriented design as working systems. If you go to the internship, or maybe in the future, you may learn something like Haskell. This one is not OOP. This is more like procedure. Since every language has their own advantages in different environments, so we cannot say OOP is the best. But it is most commonly used in the industry. The UML, the full name is Unified Modeling Language. Actually, I don't think it is a language, but it is a certain kind of tool that is most widely used in graphic scheme for modeling object-oriented systems. So in the future, if you go to a software engineering course or software application, they may require you to draw such a kind of pictures using the UML. That means, like, for example, I have a class here, like animal. And you should draw, making the analysis. In the first part is attributes. We say the name, the color, something like that. And we have a method that is run, right? It. This is a UML. This is just one certain small pieces of instances of UML. So I don't think it's like it is a language. It's more like a tool that helps you to analyze your program. And then another thing is, like, here we can also do the same thing. We have a cat class, and we inherit something here. And we always using an arrow pointing to the father, and here is the son. That means the inheritance. This is a UML, although it's not a language. It's just like drawing something, drawing a picture, make your design. For the operating systems and software and systems are that making using computers more convenient. They provide services that allow each application to execute safely, efficiently, and concurrently with other applications. And the software contains the core components of the operating systems is called a kernel. Okay, here it is pretty important thing. Everybody, you should understand. You should remember currently. It's a kernel. What is a kernel? It is the software that contains the core components of the operating systems. It is a kernel. If you are using Mac is a Linux wrapped thing. In Linux, it has a kernel there. But for the Windows, we just say operating systems. We don't say kernel. Only when we are talking something about this. Linux, we say is a kernel. And popular desktop operating systems include Linux, Windows, and Macs here. The most popular mobile operating systems is the Google Android and Apple's iOS for iPhone, something like that. Windows, here we are going to have some notions of it and about its history and future. It is a proprietary operating system coming from the middle 1980s. It's developed by the Microsoft Windows operating systems, consisting a graphic user interface built on top of DOS, and numerous popular personal computer operating systems that users interact with by typing commands. And Windows borrowed from many concepts, such as icons, menus, and windows developed by Xos Pack and popularized by early Apple Macintosh operating systems. And in our book, it says that Windows 10 is the latest operating system. However, since we are not we are at the newer age, so currently Windows 11 is supposed to be the latest operating system. So features include enhancements to the start menu, user interface, Cortana personal assistant for voice interactions, action center, and something else. And Windows is a proprietary operating system. It's controlled by Microsoft exclusively. Also, currently there are some pirate ones. They are illegal, but depends. In China, many people use the pirate one, but here in US, everything is legally used. When we are buying our computers, the producers, I mean the sellers, will already install Windows there because we have paid for the priority, the proprietary there. And Windows is by far the world's most widely used operating systems because it is cheap than the Macs. Linux is another thing. It's an open source operating system, and it is more like Mac. It is the greatest success of the open source movement. Open source software departs from the proprietary software development style that dominates the software's early years. That means the open source means free. You can make your own version. However, for Windows, it is a proprietary one, so you can make your own. You cannot sell it, and you can make it for any benefits for your own self. Otherwise, you will be sued by the Microsoft company. And with open source development, individuals and companies contribute their efforts in developing and maintaining evolving softwares in exchanging for the right to use that software for their own purpose, typically at no charge. That is free. And the open source code is often scrutinized by a much larger audience than proprietary software, so errors often get removed faster. Open source are also encouraged innovations. Enterprise systems, companies such as IBM, Oracle, and many others, they have made significant investment in Linux open source development. Here, I have to interrupt because in the first lectures, I told you that we are going to mention something about GitHub. So we will mention it there. Here. And I will return to the slide, but currently, oh, sorry. Here, I forgot. For those for those who are interested in to be an adjunct lecturer, hello? For those who are interested in to be an adjunct lecturer, you can go to LinkedIn to search every advertisement there. They will, for CUNY, they will require you only a bachelor's degree in an area's expertise. Here, as you could see, that means if you hold a bachelor's degree, you are eligible to apply for such kind of job. And for the adjunct lecturers, it's 100 per hour. So please make sure you are getting good grades in your Java programming and the other programming courses. It will help you, it will increase the possibility to secure such kind of job. I'm not lying to you. I'm just encouraging you to get good grades and get such kind of job. Because it is only bachelor degree needed. Okay, then I will turn to the GitHub. Open source. You can register for a GitHub account by yourself. And then in the GitHub, you can save your own code there. For me, I have a lot of repositories. Like this is one, it's private because I discuss the materials with my advisor. Those are codes and PDFs documents. And also, apart from to store your own codes, you can also search in some other people's codes there. Like if you want to do a restaurant system, let's search restaurant system. That is the GitHub. And then you will see a lot of open source programs there. This is other people's repository. And once you click in, and you can see their descriptions, project descriptions, purpose, contributors, something like that. And this is only the description. And you can find their codes in their folders. That's fine. Here, app, source code, main, die out codes. Oh, it's a pretty complex project, this one. And those are source code implemented by the other programmers. You can download it using Git. And you can also download their code manually using the bottom here, like download the zip, and then you unzip their code. In this case, you can write or modify other people's code to fit your own design. That is the way to use the GitHub. But first, make sure you register for your own account, and then you search something here. There is a blank here. You can type anything you want to search, like restaurant systems or educational system, you see. Let's see whether they have it. Okay. There are some educational administration management systems, but it's right in C#. However, there is a Java version, educational management systems. You can search a lot of codes and different projects in GitHub and then download it. Or you can using the instructions I uploaded in the modules in the Brightspace using Git, using the command to download it. Or you can download it manually using the download zip button. And once you made your own version, and you can upload, usually they can upload files manually, or you can using the git command to upload your code to the GitHub. But these things should be self-learned by yourself. I will not teach this because as this is a Java course, not Linux or some other course. So I encourage you to explore more. In this case, you can finish your project. Okay, let's return to our slides. GitHub is a pretty good, popular open source community, and it also contains some Linux codes. We say the C or C##, anything. Okay, let's skip it because it is not important. For the Mac, Apple was founded in the 1976 by Steve Jobs. Okay, we will skip for the descriptions here. Google's Android. This is for the mobile phone. Okay, here, programming languages. Here we are going to introduce some used, maybe not popular, but you still have to have a concept of it, like ADA, basic. At least you should know the name of it. For descriptions, it's not important. ADA, basic, C, C++, C#, COBOL. Okay, I don't even know about that. COBOL. The first time I meet it. Fortran. Jane Street, they use, you know the company Jane Street? A financial company, they provide pretty high salaries for their programmers. They use Fortran pretty much. But it's not a commonly used languages in industry. And JavaScript, Object-C, Pascal, PHP, Python, Ruby on Rails, Scala, Swift, Visual Basics. And you only need to know these names, have a concept left, is enough. And for Java, it is the most important things in this course because we are learning it. And this is the descriptions for that. For some histories, but they are not important. For this one, Java's classes libraries. It's a rich collection of existing classes and methods, also known as Java APIs. API refers to the application programming interfaces. We are using Java API classes and methods instead of writing your own versions because it can improve the programmer performance because they are carefully written to perform efficiently. This is also shorten programmer development. As we previously write something like that. If you can remember, like we knew a Java scanner. Where is? We knew a scanner, right? Scanner input. And then we assigned something to it. New scanner and system dot in here. And then we declare a variable int I is equal to input dot next int, right? We write something about it. This is the API because it is carefully written to perform efficiently by others, by the Java, the JDK itself. We do need to implement it by ourselves. It is provided by others. It is a provided thing. This is we call API. Or you can say a method name, but implemented by already built in there. A typical Java development environment we often have 5 phases. Oh, here we have to remember it. It is important because it might be included in the multiple choices in your exam. Edit, compile, load, verify, and execution. And for the phase 1, we added a file with an editor program. If you can remember in the first class, I asked you to create your own Java.file, a source file named welcome.java. We use the notepad, right? And then we use the notepad and type, and we copied our code into it. And we save it as a welcome.java file. That is the phase 1. We added it. And Java source code file are given name ending with the .java extension. Right? Here. We already conducted. And then once we have added it, that means the program is created in an editor and stored in a file with the name editing in .java. And please remember, when we are clicking the save button, that means the file will be saved in the secondary storage. That is the solid something driver. We mentioned it in the section 1.21. And the two editors widely used in Linux systems are VI and Emacs. But those two are pretty old. Currently is Vim and the Nano. Nano is using in Mac pretty often, but in Linux is Vim. However, in this course, you still have to remember these two. And Windows provide a notepad, Mac provide TextEdit. I don't know why previously some Mac users come to me to debug. We cannot open in the TextEdit, but we edit the code using Nano. But I think the Mac is supposed to provide a TextEdit in there. But it's fine. For the IDE thing, IDE, the full name of it is Integrated Development Environment. That provides tools that support the software development process, such as editors, debuggers for logic errors, and that cause the programs to execute the incorrectly and more. And that is, we say the IntelliJ, or you can use the VS Code and PyCharm. Those are all IDEs. And in the phase 2, we compile a Java program into bytecode. If you can remember, everybody is trying to use the Java-C to compile this one. So this is the for code we used in the command. Java-C space welcome.java, and then we got a new file in our folder that is a .class file. It contains the compiled version. And the Java compiler translates the Java source code into bytecode that represents the task to execute it. So the bytecode is stored, you have to store it stored in the .class file. The JVM is a part of the JDK and the foundation of the Java platform that executes the bytecode. We have talked something about JVM, JRE, and their relationships in the second lectures. So here we will not go through it. So I will skip it. Here, the bytecode instructions are platforms independent. That means bytecodes are portable. The same bytecode instructions can execute on any platforms containing a JVM. What kind of platforms here it refers to? It can refer to a Windows platform. And it can also refer to the Mac. As long as you install the JDK, you will have the JVM environment. So once you have the JVM, you can implement the bytecode everywhere. When we are using the JVM, we use these instructions, Java space welcome, to invoke the command for our program, so we can get the output. For the phase 3, loading a program into the memory, the JVM places the program in memory to execute it. This is known as loading class. Loaders takes the .class file containing the program's bytecodes and transfers them to the primary memory, and also loads any files of the .class files provided by the Java. You should know that these things only happens after you run the javac command. And only when you execute such command, you will get a class file. And for the phase 3, as the classes are loaded, the bytecode verifiers will examine their bytecodes and ensure that they are valid and do not violate Java's security restrictions. These things are all happen within the JVM. This is not manually implemented by us. And for the execution one, the JVM executes the program's bytecode, and JVM typically executes bytecode using a combination of the interpretation and the so-called JIT compilation. It analyzes the bytecodes as they are interpreted. A JIT, such as the Java Hotspot compiler, translates the bytecodes into the underlying computer's machine languages. You just need to know JIT compiler. It is a compiler. That is okay. Other things you don't need to understand currently. And when the JVM encounters this compiled part again, the faster machine languages executes. Java programs go through two compilation phases. One is the source code is translated into the bytecode. And another one is during execution, bytecodes are translated into machine language for the actual computer on which the program executes. That is, we are also mentioned previously the differences between the Python and the C++ and Java. Okay, we will quickly go through something of the other informations here for the World Wide Web. That is the www something. It is the internet we used today with email and instant messages and file transfer. Those are the internet and the World Wide Web. And the internet is a network of networks. Okay, it's a little bit complex in wording, but it's simple in understanding. In parallel with the early evolution of the internet, organizations worldwide were implementing their own networks for both intra-organizations and inter-organizations communication. One challenge was to enable these different networks to communicate with each other. The Internet Protocol creates a true network of networks, the current architecture of the Internet. The combined set of protocol is now called TCP/IP. You will learn a lot of this in your computer network course. When you are transferring out for your third and fourth year, Usually, schools will provide such kind of course. They will give you a pretty detailed knowledge about the TCP/IP. We just need to know that the internet is a network of networks is enough. And also the Internet of Things. There are something we have to remember is the internet is no longer just a network computer, it's an Internet of Things. A thing, you should know that it's an object with an IP address and the ability to send data automatically over the internet. It is a pretty important notion that concept you have to understand. That a car with transporter for many paying tolls, a monitor for parking space availability in a garage. Why a monitor is an IoT, Internet of Things? Because it's an object with an IP address, so that we can track and control the monitors. A heart monitor, a monitors for drinkable water quality, a smart meter. For those of things, they are all Internet of Things. And there is a specific course called Internet of Things. If you are interested in, you can select it in your third year or fourth year. And there are some notions you still have to know. That is agile software development. This concept you should remember. That is a set of methodologies. Agile is a set of methodologies. And for the refactoring, it involves reworking programs to make them clear and easier to maintain. So the keyword is reworking. And for design patterns, those are proven architectures. For constructing flexible and maintainable object-oriented softwares, those are architectures. For LMNP, it's an acronym for the open source technologies that many developers use to build web applications inexpensively. It stands for Linux, Apache, MySQL, and PHP. This is the important thing. And the SaaS, software as a service. Here, with the SaaS, the software runs on service elsewhere on the internet. That means if you have the internet, you can run your software. An SDK, the software development kit, it includes the tools and documentations developers use to program. Alpha. Those are also important concepts we have to know. Alpha software is the earliest release of a software, that still need under active development. And the beta version are released to a large number of developers later in the development process after most majority bugs have been fixed. So the alpha is the first version. The beta one is a more reliable one, and it is before release, before the software release. Those are the difference. For the release candidates, are generally the feature complete. Those are complete versions, usually bug-free, but not always, I think. It is only usually bug-free. So those are things you have to remember. For the final release, is the kind of the final product that can provide to the client. It's usually bug-free. However, it still have the possibilities that it contains some bugs in. Continuous beta. These concepts means the software that's developed using this approach generally doesn't have version numbers. Doesn't have a version numbers. So this means those softwares are continuous beta version. It's hosted in the cloud and is constantly evolving so that users always have the latest version. And there are some online forums for you to get your Java questions answers like Stack Overflow, Code Ranch, Oracle Java Forum. But I suggest that currently AI is pretty prevalent. You can turn to ChatGPT, Gemini. They give you a 1 year free for student. You can search for it. 1 year free. ChatGPT and the cloud will require you to pay. And another one is the DeepSeek. DeepSeek is totally free. However, it is a kind of slow. But as long as it is free, so I cannot judge it too much for its speed. I encourage you to using the AI tools because currently I was currently invited to interview with some big companies, and they are talking something. They are interviewing something about how can I using the AI in assisting me to complete my homework, my tasks, and the project. Like how I make my prompt to the AI to get the things, to get the solutions fastly from the AI tools they provide to me. So I pretty encouraged you to learn how to using AI, Geminis and DeepSeeks for self-studying and complete your homework. But by the way, even you using the AI, be sure to practice by your own, because I'm always thinking that only you practice your own code, you will upgrade your own skills. Without practicing, a lot of things will be ignored, like the difference between the double quote and the single quote. Between the double quote, it's a sentence. It is good morning, something, right? It is a sentence. We always say it is a string and included in double quote. However, we use single quote to indicate a chart. See, like A. It is single quote. If you don't practice by yourself, you may cannot realize when you are making mistakes on these two concepts in your code. So be sure to practice your own code by yourself rather than relying everything on AI. But I encourage you to learn using AI to help, to assist you in homework. It's fine. And then that is for today's class. And I have scheduled a quiz on next Thursday. This Thursday we will not have our course, and the next Tuesday we still don't have our course because the college is closed. So our next meet is on the 19th. In that day, we will have our in-class quiz. It's around 30 minutes. It is simple. It is simple. If you know how to using the ChatGPT, you can get the answer pretty quickly. But I still encourage you to complete the assignments I posted in the Brightspace first, in case you may miss some same questions in the quiz on February 19th.
Miss, I was gonna say, there's no class on Thursday.
There is no what?
There's no classes on Thursday.
No class on Thursday?
Yeah, that's what they said.
Well, okay, please wait a moment. Let me figure it out. But through their calendar to me. I will recheck. Bronze community.
Oh wait,
Unless
I'm sorry. I got confused. It's
oh
this
okay.
week we don't have.
Yeah, okay, it's fine, it's fine. So our next meet is on 19th. There will be an in-class quiz. And in the 24th, we will have our first exam. And I would recommend you to practice the 4 questions I post in the Brightspace. Be sure to practice it because I'm going to quiz it. I'm going to make some examinations on that 4 problems. Okay? It's not difficult, but you have to code by yourself. If you don't know how to code, just type the same thing I posted there and make it run. If you cannot run and you can come to my office hours on the today or on the 19th, so that on the 24th, you will know how to make your program run and make some modifications and get the right conclusions there. Okay? So if you don't have any questions, you can leave. If you have some questions, and you can stay here.
Thank you, Professor. Have a
It's
good
okay.
night.
Good night.